Okay, so what QA start with? Quality assurance. Like we said earlier, analytical chemistry is different steps, right? It all start with sampling. Okay, so it's really important to find a representative sample. The question you should ask when you are taking representative sample is, how should sample be taken and how many are needed? Okay, so here I give you 4 examples of different, examples people taking a sample and which one you thinking is the right one. Okay, so this one should be the most representative, right? Because you want to take each of the square should be one of the samples. I mean, one part of the samples, and each square need to have multiple times. So that is how you're taking the representative sample. Once you take the sample, one thing important is you need to think about how to preserve the sample. How to preserve the sample from the field, from the on-site location to the data analysis the analytical laboratory, right? So you need to consider about sample preservation and chain of custody. One example you can see nowadays, you go to COVID test, once they take the sample from you, how they can preserve the sample, deliver to the laboratory, right? That's the chain of custody. And what analytical method will be employed? And this is a really important question in order to handling the analysis to the specific sample. So in order to do that, you need to review the analytical figures of merits, which we're gonna talk next slides. Okay, what kind of property or quality you are looking for your sample in order to pick up the right tool for this job. Okay, so here I have 2 concepts. Concept you need to understand. One is called false positive. What is false positive? Here is the false positive is incorrect report percent of analyte above a given threshold. So example is, if a doctor tell a male patient, say you are pregnant. So if a pregnant is what the analyte you want to detect it, and here is definitely incorrect, right? So it's called false positive. Okay, so the other side, if you see a woman already have pregnant, but you say you didn't detect the pregnant, so it's absent of analyte, it's called a false negative. Okay, so you need to understand the difference of these 2 concepts. Okay. Okay, so what is analytical figures of merits? It is a quantity used to characterize the performance of an instrument or method relative to its alternatives. So it's a quantity to compare different instruments or methods. Okay, and in this part we're going to discuss sensitivity, specificity, how to do the selectivity, LOD, LOQ, linear range, dynamic, robustness, ruggedness, and time cost, and all the figures of merits including precision, accuracy, resolution, bandwidth, speed, and characteristic mass, MO. Okay, now I want you pause this video and write down the word sensitivity. What sensitivity means to you in the context of analytical chemistry. Okay? Welcome back. So in analytical chemistry, sensitivity refers to the ability to reliably and measurably respond to the change in analyte concentration. Okay, often it mirrors the slope of calibration curve. Okay, so what that means is how reliable and measurable respond to the changes of concentration. So here, have one example, right? You have A, B, C, D, each different slopes that represent 4 different relationship of the sensitivity. The y-axis here is the signal. Okay, it's the signal, and x-axis is concentration. So what this relationship is tells you with the change of concentration, how quick the signal is changing. Okay, so now I have a question for you. It's from A, B, C, D, 4 different slopes. Could you tell me which curve is the most sensitive? Okay, welcome back. I hope you get the answer is A. You can see if you can do this, right? You can have 2 different concentrations, C1 and C2, and you have a signal S1 and S2. And you can see by changing C1 to C2, A have a much bigger change than signal from S1 to S2 compared to B slot of this change, right? B slot have a much less change compared to A slot. So A is the most sensitive, and let alone the C and the D, okay? So A is the most sensitive because the signal changes most by changing the same concentration of the analyte. So from this plot, if you have a slope, you know y equals to mx plus b, and here if it start from 0, then b was 0. But so we can b as 0, but you can see y here is a signal, right? And m is a slope, which is a k of analyte. And times times x, here is a concentration, okay? So if you know the slope, I can give you any kind of concentration or and then you can get the signal, or I can give you any kind of any value of signal to get the unknown of the concentration. This is a math relationship between them. Okay, now what I want you is to sketch a graph for a method that is completely insensitive, and draw that in your graph and continue the video. Okay, welcome back. So I hope you draw some graph like this. It's with concentration change, the signal is not changing, so it's a flat line. So here the slope is 0, and it means it's insensitive or no sensitivity. And here the slope K analyte is 0. Okay? Now, what about this one? Is the slope goes down. So is this a acceptable calibration curve? With increased concentration, signal goes down. Pause the video and let me know what your answer is. Okay? Okay, welcome back. I hope you get answer is yes. It is acceptable. Why is that? You can add in some concentration is quenching the initial signal. You can have initial signal is, fluorescence signal, and this material A has a fluorescent signal, and material B has quench function. What that means is when you're adding B into A, the signal will decrease. So initially you will have you have B concentration is 0, okay? So you only have A. Once you start adding more B concentration, the signal goes down. Okay, so this is an acceptable calibration curve. Fair enough. So from here, what you can see is that the slope is, what value of slope is, positive or negative? So the slope is negative slope, right? Slope is negative because it's goes when the concentration increase, signal decrease. Okay, now we talk about the sensitivity. So what is the specificity? So the specificity is the degree of which analyte signal depends on the analyte. So the degree to which analyte signal depends on the analyte. So means it's how specific to the analyte. Okay. Also, the specificity is the ideal, but few analytical methods are completely free from the influence of interference specificity. So when you have your sample, you have S signal from your sample, right? You actually is adding up for your analyte in your solution and the possible interference, right? So it's the sum of your analyte and interference. So we said the S signal of analyte is K times concentration, right? Which the previous slides we just talked. And the S interference is the slope of interference times concentration of interference. Now this is specificity, okay? So just want to emphasize again that S signal here is the solution. Whatever you want to measure is a solution. Will contain your analyte. So you have a body of solution, right? You have analyte is in your body, and there are some other stuff maybe have interference. So how much the interference is depends on the K, the slope. It may be no interference. It maybe have a very significant interference. It all depends on the slope and also how much that analyte will get interference by the interference is also depends on the K. If it's very close with each other, then that's a problem. Or it will much bigger, the slope of analyte much bigger than interference, then that's no problem, right? Okay, so besides sensitivity, selectivity, another figures of merits is called selectivity. So we talked about sensitivity, we talked about the specificity. So another figures of merit is selectivity, which refers to the ability to distinguish one analyte from another species in the sample. Okay? In other words, it is measure of methods freedom from interferences. So it means how well it can pick out the signal from all the information you got, how well it can distinguish the analyte from others. Okay? So sometimes this report to selectivity coefficient, K, A, I, and interference. And this equals to the slope of interference divided the slope of analytes. Okay? Now, if you are thinking about selectivity, what the value you want to be? You want the value become bigger or you want the value is smaller? Okay, pause the video and here is a question here. You actually can answer. What method has highest selectivity given by Ka? So you want A is the smallest number, D is the biggest number. So what you are thinking about? Think about it and come back in a minute. Okay? Oh, welcome back. I hope you already choose the answer. The answer should be A. You want this value small. It's because you want the slope analyte is really sensitive, which means very high value, and you want this number is really low, which means really low sensitivity to the change of the concentration. So if that's the case, the eventual value will be really small. Okay?